All right, guys. So let's talk about how this earthquake stuff helps us identify what the center of the Earth looks like. The biggest thing is we have to be able to find the epicenter, and from that we get additional information. So let's take a look at that. All right. So what is an epicenter? Epicenter is absolutely the focus of what an earthquake is and where it occurs. So if we have a sliding of two different plates or whatever the type of earthquake we have, whether it be divergent, convergent, there's a center of where the main activity occurred. And that's what we're trying to identify when we start working through this, which is the focus or the foci, where we find the epicenter. And this is from the earthquake's origination. This is where we find that part. Okay, we're able to do this through seismograph prints, and seismographs are those machines that are famous. They have their little needle. It's kind of like a lie detector machine, and when the earthquakes occur, they start to shake, and they record the shaking of the earth. And what we're really looking at is the difference between the P wave and the S wave. So if we look at this, we have three different stations, which, by the way, all this stuff is recorded in Boulder, Colorado at the USGS, and where this stuff can be analyzed and data there and looked at on this data by geologists there. So this would be three different separate stations, and you can see that the P waves are much stronger here on station C and close together, farther apart here, and then in station A they're the farthest away, and you can see that the waves are not quite as big. So what do you think that may tell us? All right, so if we look at station A, say that was station A was San Francisco. Okay, it shows that the P wave first arrived at 3:02, 20 seconds, and then the S wave arrives at 3:06. So you can see that there's a lag time between there of what, 4 minutes, roughly 4 minutes in there. And what the P waves are is the shaking of the waves and the way they work. The P wave would be a wave that like pushes through the earth, and the S wave would be just like the wave that you think of. And they travel at different speeds. So if we know the different travel speeds, we can measure how far away that may happen in between here. Okay? And we're looking at the difference, of course, between the P and the S wave. In this case, it's 4 minutes and 10 seconds. Like I said, about 4 minutes. All right, so the next one to say was in Denver, Colorado. And this one arrives at 3:01. The other one arrives at 3:05. What's the difference between there? It looks like about 4 minutes and 40 seconds being the difference. Okay, 3:20. So this one, obviously, if we think about that really hard, we know that the epicenter is probably closer to Denver than it was in San Francisco because of the travel time of these waves. All right, Missoula, Montana. If we measure that one, look how close these waves are. Just looking, you can see they're much bigger, they're taller, and they're closer together. So these arrival times is 3:01, 3:03, 2 minutes being the difference there. That means this station was the closest to the epicenter. Okay, so if we look at all of them, you can see the difference in the arrival times in these different stations on these seismographs. And what we do is if we take and we are able to plot this, and you'll plot some of this, we can determine how far away the P wave and the S waves are. So we plot these two different separate points, and it gives us the distance to the epicenter, as well as the time it took it to travel that far along the side here. Make sure you make a note of this chart because you will be making some of these. We measure it in from the arrival, so 4 minutes away. And there we go. That's how far away that epicenter and the amount of time in that amount of time from where our station was. All right. Mark the paper and the ticks, measure it in. And then the tick marks go up the line, straight down, and read the epicenter distance. And that tells us our distance. And like I said, we'll be practicing this in some of the labs that we have. And the epicenter distance is from 2,800 kilometers. And we know that because of how far away this is measured up, 2,800 kilometers away from the P and the S wave. Okay, that's how we know, because the P waves arrive first, right? All right, so, for example, let's say we have one in San Francisco, it's 4:10. Kingsburg, Colorado reads 3:20. And Missoula, Montana is 2 minutes away. We go through the chart, we determine how far away, 2,800 kilometers away, San Francisco. Kingsburg happened to be 2,000, and Missoula was 1,100 away from that epicenter on our chart. We measure this out in our distance, and we want to open up our compass to that distance on our scale to our map. Okay, so on a map we have the scale, how far away things are. We can set our compass to that. Take that compass, and if we measure it, we use the first one, and we draw our circle from San Francisco as 2,800 kilometers away. And then we would do Keensburg, which is 2,000 kilometers away, and then finally Missoula, which is 1,000. These circles will intersect. When they intersect on the map, this tells us the epicenter of our earthquake. That's how we know where they occur. And the animation, of course. And that's it, the epicenter. All right, guys. So this is what the epicenter, how we find the epicenter in the earthquake. We'll learn how we know what's in the core of the earth. We've seen that. And at this point, we'll be able to practice finding the epicenters now. All right. I'll talk to you later.